Looking at percent composition, empirical formulas, and molecular formulas relies on the fact that the samples of matter that we're looking at are pure substances. They have a defined and constant composition. They're made of certain elements bonded in certain ratios that don't change. Mixtures are the other side. So if we scroll here, all of these are pure substances. We could go to another set of flow chart here that's mixtures. And they could be homogeneous or heterogeneous, which isn't quite as important here. We won't spend as much time with mixtures in terms of their details. But what's key to a mixture is that it's not always the exact same mixture or the same ratio. It's not always uniform throughout, although it could be or could look uniform. The key is that they are not combined. That's why and how the components and the amounts of them aren't defined. So right here, this could be lots of different things, but salt water would be an example. You can always sprinkle a little bit more salt in or add a little bit more water to it. It's still the same two chemicals or substances, but they're in different ratios, and there's not chemical bonds holding them together. So right here, this might be oil and water based upon the way that it's separated there. But we have some things here. And look, we see some differences both in terms of the numbers and the arrangements and the ratios there. It's not uniform. Because each of the components, though, has a chemical formula, each one has a different property, so they can be separated. The simplest is filtration. We've probably done that before. We'll do that again. That's how we get a solid away from a liquid, as long as the filter paper is kind of set to the size of the particles. That's the easiest one, but there's also filters that even work on dissolved things. Maybe in your house, you have a water treatment system. Distillation is another thing we might do, but is important to know. Different substances have those different properties. One thing's a difference in boiling points. So this isn't technically distillation, it's evaporation. But if you heat up salt water, the water boils away, the salt stays. If you heat up oil and water, in that case, depending what the oil is, one would boil away, probably the water, and the other would stay behind. So we separate them, and there's even apparatus that allows us to collect the two parts there. Chromatography is something we'll probably do, but it can happen in gas, it can happen in solid states. There's lots of different types of chromatography, but they're all based upon the fact that these different substances dissolve differently and attract to things differently. Intermolecular forces. And then another one is sometimes one of the things in our mixture would react, whereas another one wouldn't. With the example of oil and water, we could react the water with something the oil doesn't react with, or vice versa, trying to get one to go away. In any of those, we could figure out how much of one thing and the other thing are there. So when we are separating it, we would use one of these, make some measurements before and ever, mass, concentration, other things like that, and then talk about or compare those. And another piece of this is that mixtures, a lot of times we want to have a mixture. We might want salt water. We might have made oil and water. But every now and then we want a pure substance. We want maybe pure salt, but something else is mixed in there. Could be sugar, could be any other white powder. Analyzing that salt that we think is pure is a way to test how pure it is. We're trying to see, is this thing pure substance or a mixture? So even if we're just talking about one chemical formula, we might still have a mixture there that we want to prove is or isn't a mixture. So we've got some techniques down here, but they're not maybe as simple or straightforward as empirical molecular formulas and percents, but they are based upon knowing the amount of one thing based upon data, the amount of the other, and then making that comparison.